everyone. It's April 3rd. I did the bi-weekly contest yesterday. It was terrible. Only was able to do 2 questions. It was in the morning. I was actually quite lucid. I feel quite good, especially after the first 2. I felt quite good. And the third one, I thought I got it, but my God, I got timed out. So yeah, that one is still undone. So I'm gonna try to look at this one as well. But first, let's try to do the challenge today, which is next permutation. Well, it's an old problem, very old problem. Wow, that was 4 years ago, 3 years ago. All right, let's see. A permutation. We know what permutation is. The next permutation of an array of integers is the next lexicographically greater permutation of its integer. Well, formally, if all the permutations of the array are sorted in one container according to their order, then the next permutation of the array is the permutation that follows it in a sorted container. For example, the next permutation of this is swap these two. 2, 3, 1 is, yeah, because that's the largest, starting with 2, right? So the next one will be 3, and then smaller, 3, 1, 2. Yeah. It was already the largest, so we have to go back to the start. Given an array of integer, find the next. It's a good question, very good problem. All right, how would you solve it? So we have just numbers, right? Just numbers, it doesn't really matter. So we have 100. Apparently, we cannot get all the permutations out. So we need to create the next permutation based on what we have right now. Now, what we have right now, it has an order, right? It has some level of order to it. So the question to ask is, does the first element need to change? Now, how do we know if the first element needs to change? Well, we'll know that if the remaining is the largest, right? And how do we know the remaining is the largest? So basically, if the remaining is the largest, then we need to change the first. If the remaining is not the largest, then we ask if this, the second one, is the largest, and then we change the remaining, right? So what are you saying? Well, what I'm saying is, if it's not the largest, if we have found down to the right-hand side, if we have found some elements that currently is not the largest, right, then we can make changes based on that, right? Because it's not the largest, so we can always find a larger based on that permutation, so we don't have to change anything in the front. So we should go from right to left and find the first element that is not the largest, right? So for example, here we have, we don't have to consider a single one, it doesn't really matter. Now we find this, and we say, is 2, 3 the largest way of organizing 2, 3? And then we say no, because 2 is smaller than 3. So we can find a larger version of these two values, right, of a permutation of these two. And how do we find it? So if we go from right to left, right, we keep comparing if it's larger, if the next one is larger than the previous one, and we find the first one that is smaller than the remaining. So we say, okay, so we are able to find a bigger one. And we're saying that the remaining is always the largest. And we'll find the first one that's smaller. So what we need to do is, we're going to swap, right? We're going to swap, and it says do not return anything. We modify it in place. Doesn't matter. So we need to swap. So we need to swap something that's just, barely larger than this, right? Because we want to find something just slightly larger, not the largest, right? Not the largest. So we need to find. Well, we can binary search in this way, but we only have 100. So actually, binary search might not be the smart idea. We can just go search for it. But anyway, so the idea is we're going to look for the value that's just the smallest value that's larger than this. We need to swap this out, right? And then for the remaining values, we swap yes, because this one is just larger, right? This one is just, everything is larger. We swap that, and then we reverse it. That's it. And in this case, we keep finding, and then we don't find anything. Then we just reverse the entire thing. Let's try this. Now that I'm, talking it out, I kind of remembering how this one was solved. It seems like I have, it seems like I've done it before. Of course, I've done it before. I know I have done it before, but the method seems to come back. This swapping idea seems to come back. All right. Okay, so the idea is we're going to go from, so we're going to say, for I in range, let's say len nums -1, -1, -1, right? Oh, actually -2. And we say if nums I is smaller, well, how about equal? Equal, it has to be smaller. Nums I +1, right? If this, we're gonna break, right? And else we just need to reverse. All right, it seems like we need to write a function called reverse because we have to do it in. So def reverse self nums. So yeah, I'll call nums. So basically this one will reverse everything inside. So I'm gonna say low high equals 0. Ooh. Let's also put low and high, so we don't have to. So low and high is in there. Okay. While low is smaller than high, we say nums low, nums high equals nums high, nums low. So we're swapping them, and then low plus equal 1, high minus equal 1. That's it. So that's the reverse. So this else means we go through the entire list and we have not found a case where the current value is smaller than the value to the right. So in this case, we just call self.reverse 0. Well, we have to go nums, passing nums, and then 0, and len nums -1. And we're done, right? Then we return when we're done. Otherwise, we break out. So we know nums I is smaller than the right. So what we need to do is for j in range from I +1 towards len nums, right? So from I +1, because I is the smallest, so we find the first one. If nums j, find the first one that is smaller, okay? Find the first one that is smaller or equal to nums I, right? So the first one is smaller or equal to, then we're gonna break. We can always find it because nums I is smaller than this, so they gotta be, right? They gotta be one value. What if every value is larger? Good question. What if every value is larger? So we're going big, boom, the smaller, and we try to look for. Well, if everyone is larger, it doesn't matter, right? It does not matter. We just keep looking. So if nums j is smaller than this, then we break, right? Otherwise, at the end, will come out nums j, like j should be the one we choose. Now, now that I think about it, because this one stopped at length minus 1. So actually, it will be better when you say j equals I plus 1. I say while j is smaller than len nums, and nums j is larger than, because equal, we don't want equal, right? So if it's larger than nums I, then we do j plus equal 1, right? We also keep pushing j back to the right, and every time we check if this is larger. If it's larger, we just keep going, because we need to find a value that is smaller or equal to now this is interesting, because if we do this, if we find something equal, we want to swap. Well, if we do a swap, does that work? This is the largest, and now we find the first one that's smaller, and we find something that's equal. And if we do that, that's not the next one. So it has to be, if it's larger or equal to, we keep going, right? J plus equal 1 plus equal until we find one. So we find one, either it's smaller, right? Wait, hold on. What are we trying to do? I see. I want to find the first one that's larger than. So yeah, it has to be larger than. So whenever we find it's equal, then we need to jump out, right? If it's larger than, we go to find one. So eventually it will jump out. Either j is equal to len nums, so we exhaust the entire list. But that's also fine. That's also, we just need to find the first one. The smallest one is larger than nums I. So the smallest one will be j minus equal 1. That will be the one, right? That will be the one. So once we settle that, now we can do the swap, right? So we're going to say nums I, we're going to swap nums j equals nums I, nums j, nums I. So we swap I into the red, and then we reverse the red. So we call self.reverse, right, nums, and the starting point will be, what's the starting point? So we swap, starting point is I plus 1, end point is len nums minus 1. And we return. Oh, we don't need this return because that's it. All right. Test. So 1, 2, 3. Right. Shall be 1, 3, 2. 3, 2, 1. That one shall be 1, 2, 3. It's the last one. 1, 1, 5. 1, 1, 5 shall be 1, 5, 1. Okay. The test will be a little bit different. So in nums, there's no rest. So we basically just say next commutation nums, and if not rest, there's no rest, it's just nums. Otherwise, answer and nums. Actually that doesn't work. Alright, change it back. Alright, so we're gonna do this. Rest is equal to nums, copy it, okay? So copy it, and then we can call res. And then, all right, that works. I mean, the only thing that can make it slightly faster is instead of doing this, we can do a binary search. I kind of don't want to do binary search. Well, do you want to do binary search? Do you want to do binary search? Debating. I'm debating. $100, no need. All right. We can actually do some wacky whack. How about this? looks good. Try it. We got it. So not too shabby. Not too shabby. Kind of redeemed yesterday's performance. All right. So this is yeah, this one I should remember, right? I should remember. This is from 31. Okay. Yeah, I kind of remember the solution to this problem. We search from right to left, right, to locate the first number, first element that is smaller than its neighbor to the right. This element needs to be swapped by the smallest element on the right hand side, on the right, that is bigger than it. After the swap, we simply reverse all the elements on the right. And that's it. And I call it ON because it is ON. We do this, that's ON. This is ON. This is ON. This is ON. So that's ON. 49 and 71. Let's just take a quick look at the solution. Brute force is not recommended. Single pass. Oh, we can do a single. Oh, is this considered single pass? People complain in 2018. All right, so, oh yeah, that is. We swap with the first one, and then we swap. And we do reverse. We have a reverse, and I simply go in here. Yeah, I'll try to find the first one that's smaller and then swap. Yeah, that's it. So, we're good on this one. All right, let's go back to this problem. Can we... I need some hints. See, this is what I have. This is a stupid thing I have. I got timeout. So the problem is quite straightforward. Like you have a bunch of zeros and ones, right? And then you try to find out the number of ways you need to do in order to produce 0, 1, 0. Now I will find my original solution. This is a good problem. I need some hint. Look at this. Look at this. Because my solution is O(n) squared. That's why it's not working. Yeah, I'm gonna get this one back. Actually, not this one. I think I have a better one. Yeah, I think this one's a better one. Okay, I'll get this one back. I'm pretty proud of this one, even though it times out. And on the right, TLE on this. Okay, okie dokie, that's fine. Let's check. So if we have any hints. Oh, we got 4 hints. Alright, so what I have got is you have a bunch of 0 and 1s, right? We want to find the number of valid ways to reduce this string of 0 and 1s into either 0, 1, 0 or 1, 0, 1. So what I got so far is we'll group these together. So we'll group this string into 0, 1, 0, 1, 0, 1, 0, 1, like that. And as you do that, you know the total count of the zeros and the ones, and the 0 and the 1s. So at each position, you know the total number of counts. And then I was trying to optimize it, so I was using prefix sum for all the zeros and all the ones, and that's basically this solution. But we still have this part. It requires me to do O(n) squared. So I don't know. This is a. Oh, by the way, so I was only able to solve 2 problems, and I got stuck on the third one. So I solved the first 2 in 7 minutes, and I stuck on this one for the remaining of the time. And after the contest is over, I checked the leaderboard. The first place took 4 minutes. So this is not that hard. I'm pretty sure this is not that hard. I just got stuck at some place. All right, so that's what I was at. So let's take a look at the hint. Hint number 1. Yes, that's what I got. Hint number 2. Count number of subsequences of the form. Oh, hold on, that's different. 0, 1 or 1, 0 first. Be the number of 0, 1 subsequence that exists in the prefix of S up to the ith building. How can you count the number of subsequence of the form? That's interesting. That's very interesting. Count the number of subsequence of form 0, 1. So 0, 1 is the edge. If you think about that, it's edge detection, right? So that's edge. But what about 1, 0? And they say, be the number of 0 and that exists in the prefix of S up to the ith building. The number of 0, 1. Okay, let me think. So the number of 0, 1s. So we're given this string, and then we find the number of 0, 1. How does this help? Give me an example. Let's do the 38. So we have 0, 0, 0, 1, 1, 0, 0, 1, 0, right? So we find the number of 0, 1s. So I have 2 0, 1s. How does that help? Well, I mean, I can get that from my method as well. The number of 0, 1s. Well, not only number of 0, 1, I also get a number of 1, 0s. But anyway, so I got a number of sequence in the form 0, 1. Oh, my bad. 0, 1 or 1, 0. Let's consider both. Okay, 0, 1 or 1, 0. So we got 3. 0, 1. No, hold on. 0, 1, 1, 0, 0, 1, 1. Actually 4. We got 4. So we want n01I be the number of 0, 1 subsequent that exists in the prefix. So if we say n01, that's an array, and then right, so it'd be 0, 0, 0, 1, a 1, 1, 1, 2, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that's number of 0, 1s. How about 1, 0? Yeah, just consider both. So 0, 0, 0, 0, 0, 1, 1, 1, 2, and 2. Okay? Alright. I got them. So now what? So if I had a certain position, let's say I know I have certain number of 0, 1s. Okay, so at a certain position, I have some value. I have some count of 0, 1s to my left. Okay. then well, like I need to know how many zeros I have to the right in order to know how many ways I can make this. Hold on. Let's read the question again. So in the question, it says you want to select three values, right? So I say select three values is equivalent to discarding, but still, when you count the 0 ones, right? When you count 0 1, you know what? No idea. Keep reading. Hit number 3. Let n0 and n1 be the number of 0 1 that exists in the prefix of this, up to I respectively. Okay. Then n01i equals n01i minus 1 if I is equal to 0. Otherwise, hold on. Otherwise, n01i, the number of 0 ones, equals number of 0 ones this plus number of zero up to this point. No, hold on. Count the number of subsequences of form 0 1. That is subsequence. That's not subarray. So we're counting all 0 1s. So all sorts of 0 1s that we can find. We're finding all 0 1s, so that's not right. Hold up. Let me redo this. Let's do the n0. This is easy to do. N0 is easy to do, and n1 is 0 to do. Okay, so n0 will be 1, 2, 3, 3, 3, 4, 5, 5, 6, 7. Right? And n1 is also easy to do. And 1 will be 0, 0, 0, 1, 2, 2, 2, 3, 3, 3. That's n1. So now we want to find n01. How does n01 help? So n01 is the total subsequences, right? Subsequence of 0 and 1. There are different types of 0 and 1s that we can find. So let's say, hold on. Let's say at a certain position, I know the total number of subsequence of 0 1s and before. Like I know n01 I minus 1, right? And then I'm consider n01 I, and consider this one. I know, let's say the previous is that many of 0 1s. And now the current one coming in. If the current one is 0, then it doesn't change. Correct. If the current one is 1, right, then it's the total number of previous 0 and 1, right? The previous 0 and 1, and the current I coming in is 1. So the previous zeros, because all of them can pair with my current 1. That is correct. Now I see this point. This point is correct. So I can build n01 by using n0 and n1, right? Yes. If the current is 0, now we cannot build another 0, 1. But if the current one is 1, then we can build a new 0, 1 by counting the total number of zeros previously, and 0 I minus 1 plus this one. Okay, I get it. So the purpose is to build how many ways we can do 0, 1 and how many ways we can do 1, 0. Okay, so the solution will be what? So I got all the 0, 1s, right? So I have to the end. I know the total number of 0, 1s, but the result asks me to find 0, 1, 0 or 1, 0, 1. So if I have 0, 1 towards the end, so I have that many of 0, 1s, how do I know how many? Hold on. If I have 0, 1, right? I mean, I can take the remaining zeros. That become 0, 1, 0. Let me think again. So I'll have 0, 1. Let me just see if we will double count. That's my fear, that we might double count. So if I, like at the ith position, I have certain number 0, 1 to my left. And I say they can all pair with any zeros to the right to form 0, 1, 0. So if I get those, and we keep pushing forward, right? We'll keep pushing forward. And then that and those can match with anything. Then we have double counting. So what we need is at each position the new 0, 1 coming up to match with the remaining zeros. You see what I'm saying? The new 0, 1s. So at each position, like at a certain position, if we have 0, it doesn't matter if it's 0, 0. At a certain position, we have 1, right? And then we're going to find all the zeros to the right. So I have 0, 1 on the left, all the zeros on the right. Good. So that's 1. And then we keep moving forward. And if it's the same, then we don't do anything because we have not found a new 0, 1 construct, which is still the same 0, 1 construct. If we count it, that will be double counting. So we keep looking until we found a new one, right? Until we find a new one. So once we find a new one, we okay. So what do we mean by this? So it's as we're building up the 0, 1 array, we're not really building up the 0, 1 array. We are checking when a new 0, 1 comes into being, right? How many new 0, 1 comes into being? And that means as we go through, if the current one is 0, right, that means there's no 0, 1s coming into being. But if the current one is 1, then we have that many new 0, 1s, and all of those new 0, 1 construct can form with, how do people solve this? This is, wow, this is next level, man. I admit this is going to be great. So this is my solution after reading 3 out of the 4 hints. All right, so what we need. So the number of zeros, we do need all of them, unfortunately, and number of ones, we need to all of them. But the 0, 1s, we don't need the array. So n0, right? n0, n1. Okay. Then for letter in S, right? If letter is equal to, I don't know, if letter is equal to 1, right? Oh, do we have to start with 0? Let me think. It depends. It depends on. Yeah, let's do 0. That's fine. Okay, if it's 1, then n1 dot append. All right, n1 dot append what? n1 dot append. What's the purpose of doing this? I just want to know the total number. All right, yeah, we do need the entire thing. Okay, so yeah, still, hold on. Number of n1. Back to our old construct. I just feel like it will be easier to do it the other way. To find a 1, I need to know a total number of 0. So every time I find a 1, hold on. Every time I find a 1, then we just need to know the total number of zeros on the left, because they can all form new 0, 1s with this 1, right? And then the total number of 0 on the right. See, this is different. This is slightly different from what this one is saying. I just want to know the total number of zeros on the left. So every time I find a 1, right? Every time I find a 1, we have a chance to build a new 0, 1, 0. Every time I find a 0, we have a new chance to build 1, 0, 1. But how do you know the number of zeros to the right? Right? You still have to do this. Okay, you got me convinced. So there's going to be append, I don't know, n1 minus 1 plus 1, right? And n0 just dot append n1 n0 minus 1 because it doesn't change. Else will be the same thing, but this does not change, and this one plus 1. Okay. Let me see if n0 and n1 makes sense. Not print. Come on. We want to print them. All right. Let's just run this and see. Yeah. I think that's what we want. Okay. So now we have what we want. Now what? Now we're gonna go through this one more time. Right. We're gonna have rest equals 0. And we're going to go through this thing one more time. For letter in O, we're going to have I as well. So I, letter in, enumerate as bought. All we need to know is just be careful. Okay? Be careful when we query this one. We have to go plus 1. That's fine. Okay, so we say if letter is equal to 1, right? Then we need to know the total number to the left and total number to the right. So the total number to the left will be n0 I let's see. So I is the original, so this is 1, so it's actually I minus 1, right? But I cannot do I minus 1, I minus 1 plus 1, so this is I times n0, right? Not n0, n0 to the right, okay? To the right. How do we do to the right? It's going to be minus 1, the rightmost, minus what? So we're gonna go I plus 1. So I cannot do I plus 1, we need minus I, right? Minus I is actually I plus 1, so it's gonna be n0 I plus 1. So that's that. Okay, so we're gonna do this and say rest plus equal to this. Else, same thing. Rest plus equal to just gonna be I don't know, n1. because that's to make 1, 0, 1, right? And if it's 0, then just 0. And then we return rest. This, I think, this is on. Oh, this one works. Holy guacamole, it works. Huh. No, I did not think about that. I think the reason I did not think about it is I got bogged down into the idea of grouping them together. And this is not grouping them together. This is realizing that the end result is 0, 1, 0 or 1, 0, 1. So every time we find a 1, right, each one we find, we can build new 0, 1, 0, just need the total number of 0 to the left until number 0. I should put it that way. This is an easy problem. Okay, not easy, but it is a medium problem. Wow. I do not feel good because I didn't solve it. Oh my god. It's a good 58. Yesterday, my solution solving this takes 1,000 milliseconds. So this one definitely is correct. All right, so just in case. Oh, we passed all these. Now we can submit. Yep. Yep. Wow. Okay. I was stuck with the idea that this problem needs grouping. All right. By grouping, I mean count all the consecutive zeros and ones as 1, 0, and 1, 1, with the number of repeats tagged along. I thought that was definitely the way to go, but it didn't work. In fact, this problem is quite straightforward, right? Straightforward. We know that the end product, right? The end product is 1, 0, 1 or 0, 1, 0. Thus, we can think we shall, right? We shall. Thus, if as we loop through S, right? Any 0 we find, we can create a new way of producing 1, 0, 1 by counting the number of ones to the left and right of this 0. Similarly, any 1 we find, we can create a new way of producing 0, 1, 0 by counting the number of zeros to the left and right of this 1. Thus, the problem becomes how to count the number of ones or ones and zeros in any given any given range, right? Now this is an easy problem to solve using prefix sum. That's it. That's it. On. On time. On space. I feel very stupid. I wasn't able to solve this. Now I see how people can solve it. And yeah, the intuition, right? The intuition. I don't know. This is very good. This is very, very good. I like this. This is a good problem. Let's see how people say in the comments. Oh, we can do O1 space. How do you do O1 space? How do you count using O1 space? Oh, shoot, you can. I need to know this, right? That's the only thing I need to know. And then this one can be produced from, because I am at I, right? So I know this one. I know this one. Because I can just keep counting. Hold on. This can be done in O1 space. All right, let's dig it a bit further. Let's try O1 space. How do we do O1 space? So we do need to know the total number of zeros or ones. And that is easy to do because we can use count, right? So we can just say total 0. I just say s.count 0. Total 1 equals len(s) minus total 0. Okay, so we got these two. So we don't need these. And we need to go for I, right? And we need a previous count, right? We need a previous, so not the previous count, is the current count. So current count 0 and count 1, both equals 0. Okay, it's fine. It's fine. So we need to say I and the letter in enumerate. Okay, enumerate s. All right. So if I is equal to 1, right, and the rest, I'll put rest here. All right. So if the current letter is 1, right? So to the left side, I have the current count of 0, right? So current count of 0, we good. What you need to know, we just need to know, okay? So what we just need to know is res shall plus equal to current count 0 times total 0 minus, because I is so I plus 1, right? That's what we want, I plus 1. But I might be the last one, so that's something I need to consider. So why don't we not go to the end of S? Right? Let's say we just don't go to the end because there's no point. So that would be the last one we want to go. We don't want to go to the end. So we just don't go to the end. And if we don't go to the end, then we can say si plus 1, right? If this is equal to 0, right? Equal to 0, and then this Boolean value, we can actually do count 0 plus this. Hold on. That is not correct. I just realized. That's it. That is it. Because the total minus the current count, because the letter is 1, right? So total minus the current count, it is the remaining number of zeros. So that's it. And because we're not changing, so that we don't even have to do this. It does not matter. It does not matter. So basically that's that, and we just call current count 1 plus equal 1, all right? And then else we do current count 0 plus equal 1. And then we do current count 1, 1, and 1. Oh, this is all one space. Update. We can do this in O1 space. Brilliant. Brilliant. This is brilliant. Holy guacamole. This is brilliant. When in the total, wow. I'm going to throw this one into it. I don't think it'll be, yeah, I think it'll be faster. Because we are not creating the array. One pass. Oh, too few people doing it, so this percentage doesn't mean anything. Yeah. Ooh. Without the need to build array, to build a DP array, runtime reduces to 689. Wow. I am very impressed. Very, very impressed by this one. Oh, this is such a good problem. This is such a good problem. Yeah. Let's do this. I love it. You're breaking it down. It's very simple. And you can, I mean, this is the type of problem that you can ask in interviews. Like, I can imagine myself starting with this. Kind of, it's complicated, it's dumb as O(n) squared. And then the intro will be like, can we improve on it? And I'll be like, I don't know, I don't think. And then we're like, okay, how about you just take a step back? Don't think about it combining all the things together. So like the end product, you realize is 0, 1, 0, right? So what does it mean that if we find a 1, right? Just kind of introducing this idea to them. And we're like, okay, if you find a 1, does that mean you can create a new 0, 1, 0? And I'll be like, if you find a 1, all I need is the number of zeros on the left and the number of zeros on the right. I'm like, oh yeah, I can do this in O1. And then I'll write the solution with O(n) time and O(n) space, right? Because, you use prefix sum to easily get number of zero, a number on the left, number on the right. And then after that, like, okay, one more follow-up question. Can you do it in O1 space? And then you start thinking, yeah, maybe I can. And then you just fiddling with it, eventually get O1 space. Very, very good. Good. That's that. That's not the end. I have one more problem I wasn't able to solve from yesterday. I didn't even read it, this one. So we'll have to look into this. I don't have any submission for this. All right, so we'll do this some other time. Oh wow, this is pretty tough. Anyway, all right, that'll be it for today. I'll see you guys tomorrow. Adios.